Electrostatics is the study of stationary charges. So when I talk about the stationary charges, you will definitely ask me, sir, is there any mobile charge? Moving charge. What is that? Moving charge. When the electronic charge, that is, what do you mean by charge first of all? Q into N into E. Okay. So Q is equal to, you can explain this as a Q as charge. You can come and write. Q is equal to, you will be my volunteer today. So Q is equal to the quantity of charge. And N is the integer. What is N? Integer. It can be 1, 2, 3 up to Avogadro's number, even beyond that. So integer. N is integer. E is the charge of electron. The charge carried by one electron. So what is that? E is equal to, now even beyond that, you can simply put integer, that is enough. Okay. Then E is equal to 1.6 into 10 power minus 19 coulomb, right? So this is 19 coulomb. This is the charge of electron. Okay. And you have another equation also. Q is equal to I into T. That is how long you are passing the current. Q is equal to capital I into T. Capital I into T. Where I is the current. It is the current strength. It is passed through a particular conductor. So current I. That is given in ampere. Okay, so what is the unit of I? It is ampere. And what about T? That is the time of passage of current. How long you are passing the current. For example, you are charging the mobile or any electrical gadgets, means how long you are passing, and based on that you are getting charged, is it not? So T is equal to time and its unit is second. Therefore, Q, what is the unit of Q? Coulomb. So 1 coulomb is equal to 1 ampere second, is it not? So 1 coulomb is equal to 1 ampere second. 1 coulomb is equal to 1 AS. Right? Okay. Now, so we have two formulae. One is Q is equal to NE, you have put it in the box. And similarly, you can put another box for Q is equal to IT. And you can write IT properly. I. Good. So, now we have two equations. Are you able to follow? Right. And so let me have another strategy. That is, we should know something about Faraday also. So Faraday is equal to the Avogadro's number into the charge carried by one electron. So F is equal to capital N into E. F is equal to, you can put F, capital F for Faraday. F is equal to capital N into E, where capital N is equal to what? Avogadro's number. Okay. So Avogadro's number, N is equal to Avogadro's number. Put N, capital N is equal to, write down capital N is equal to Avogadro's number. You can write here, Avogadro's number. And E, as usual, you know, that is the charge of electron, 1.6 into 10 power minus 19. Okay. So now let us work out here. Let us multiply this. F is equal to, take down, F is equal to, and we can multiply 6.023 into 6.023 into 1.6. You can put 1.6 properly. 1.6 there. 1.6, put point properly. So 1.6 into 10 power minus 90. So you can multiply both and you are able to get how much? 9.64, is it not? Into 10 power 4. So that is nothing but 96,400. So the rough value can be even 96,450, 480. So roughly you can state as 96,500 also. So 96,500 coulombs is equal to 1 Faraday. That is 1 farad. Do you understand this? Okay. So you must remember all these units, right?
So coulomb only.
Yeah, coulombs. That's it. Okay, right. Now, So in this wonderful topic, that is electrostatic field and the charges, I was explaining about the electrostatics. Electrostatics is nothing but the study of what? Stationary charges. The study of moving charges, that is current electricity. When the charge is moving means, and unidirectional flow of charges, electric charges, is nothing but current. Is it not? So now we are starting the electrostatics, and the electrostatics here we can divide further as electric charges, electric force and electric field as the first topic, and as a second topic we have electric potential and capacitors. In fact, capacitor is the device with which we can store the electric charges. Okay, right. Now let us proceed, and we will try to discuss the important topics here. You have electric field, and before that you should know what is the electric force first of all, and electric field, and what are the properties of electric field. Then I'll be discussing about the continuous charge distribution, how the charges are distributed, how to determine the charge, and what could be the interaction between the two charges. It can be either similar charges or dissimilar charges. Then I'll be explaining about Gauss law, then applications of Gauss law. So these topics come under your first lesson, that is electric charges and electric field, right? Okay. Now let us have some idea about the electric charge. When I say electric charge, it may be positive or negative, is it not? So this can be represented by a point charge. So this is the point charge, and you have got the minus and the plus. You have got minus here and you have got plus charge. Now what happens is, you can find this is point charge, and always the electric lines of force will be merging, that is a meeting at the negative point. And in the case of a plus, it will be moving away from the center point, that is the plus charge. So this you must remember. So even though it is drawn as a planar one, two-dimensional one, but you should remember this charges or the field lines will be spreading around the respective charges. Okay, three-dimensionally. It means it can come above, in this direction, okay, etc. So you have to draw this diagram. I hope you must remember, especially in electrostatics, especially in physics, the arrow mark, the directions are very, very important. If you change the arrow mark, it will change the concept. So you have to be very careful about the arrow mark. So in the case of minus, you know very well, it is merging at one point. But in the case of plus, they are coming out from the plus. Right. Now, let me explain about the field lines here. The field lines goes away from the charge, as I have indicated in the positive charge. Okay, please take down. Electric field lines, they go away from the positive charge. So you can observe here, see, in the case of plus, they are moving or going away from the positive charge. And what about the negative charge? They are moving towards the negative charge. And in the case of positive charge, the Q is greater than 0 because it is positive. Whereas in the case of negative charge, the Q is negative, that is less than 0. So you can put positive here and here negative, because the charge of electron here is taken as a minus. But in the case of this one, the positive charge is taken into account, so it should be called a plus. Of course, the charge carried by the electron is equal to that of proton, but they are in opposite nature. Do you understand? And the electric field starts from the positive charge. Remember, whereas electric field ends in the negative charge. Now, I am keeping both this positive and negative together with some distance. So here you have to observe the electric lines. In plus, as I already suggested, it is emerging out of plus, is it not? Whereas in the minus they are merging, that is meeting. So here they are moving away, whereas here they are coming closer. And not only that, from plus to minus, the electric lines will be moving in this direction, from plus to minus. And they don't overlap each other. Are you able to follow? Now the field lines, as I already mentioned, start from the positive charge and ends at the negative charge. Suppose if there is a single charge, then it may end at infinity. Okay, it goes on if it is a single charge. Okay, like in this case, this is a single charge, it goes on infinitely. But in this case, it may reach the other point like this. Here, it may go here. Okay. And the next point is, it always adopts a smooth curve. And also, two electric fields never intersect each other. And you cannot get a closed loop also. So the electric field lines form tangent. That shows the direction of field lines. So these are the key points as far as electric field lines are concerned. Right. Have you noted down? Next. Now, we have discussed this aspect already. That is, Q is equal to the integral multiples of electronic charges, and Q is also equal to IT. So, from this, I is equal to Q by T. It means I, that is ampere. This is as a unit. Okay. So, Q by T, which is nothing but that is coulomb per second. Therefore, 1 ampere is equal to 1 coulomb per second. When you write the coulomb in a symbolic way, you have to use the capital letter C. When you want to write the name of the inventor or discoverer, you have to write in small letter. Okay, this is the convention we follow. Since we use only symbols, we can use the capital letter C, that represents coulomb. S is small letter. So coulomb per second. So what is the expression for 1 ampere? 1 coulomb per second, right? And what is coulomb? 1 ampere second. Okay. And here that we should note down the dimensional formula of I also. So there is no mass, there is no length, there is no time, but you have got A. So you can simply put A.